Good morning, 7th graders. Today we're going to learn how to solve two-step inequalities. Okay, and for our learning target today, I can describe how to solve two-step inequalities. Quick explanation and a quick, just a reminder here for you. You solve these the same as two-step equations. So if you think back to when we talked about solving two-step equations, this section is going to be almost identical to that. Okay, so remember when we talked about solving two-step equations, I talked about order being important. And my example that I gave you was that in the morning, I put on my socks and then my shoes. But at night, when I get home, first I have to take my shoes off and then my socks. And why was this important? Yeah, Mr. Gels, that's pretty obvious. Why do I need to know that? Well, because when you are solving a math problem, you have to follow a specific order, right? That's PEMDAS. Okay, parentheses, exponents, multiply, divide, add, subtract. But when you are undoing a problem, so you are taking your shoes off rather than putting them on, you have to do PEMDAS in reverse. I'm going to put reverse PEMDAS. So when we are undoing a math problem, we need to first undo our addition or subtraction, and then undo our multiplication or division, just like we did in two-step equations. Okay, so if you don't quite remember that, it might not be a bad idea to go back and watch the tutorial on two-step equations or a quick how-to on that. But let's dive right into some examples here. I've got 5x minus 4 is greater than or equal to 11. And then graph the solution. So here's my inequality. I'm going to split it down the inequality sign, so I have a left side and a right side. When I'm undoing a math problem, I'm going to do my addition or subtraction first. So to undo subtracting 4, I would add 4 to both sides. And subtracting 4 and adding 4 would give me 0. I'm left with 5x is greater than or equal to 11 plus 4 is 15. And now it's a one-step. 5 times what number is greater than or equal to 15? Well, you could also think to yourself, how do I isolate my x? Well, right now, when 5 and x are smushed together, that means to multiply. To undo that, I would divide by 5 on both sides. So x is going to be greater than or equal to 3. Okay, and then just when you graph, I think you've probably all got a lot of practice graphing in now, but start with my number in the middle. Numbers to the right are greater. Numbers to the left are smaller. Closed circle because it's or equal to. And my answer is for all values that are greater than or equal to. So greater than I shade to the right. Okay, I'm probably not going to graph for every single one just for time's sake of this video. But if you do have more questions on graphing, I'll be glad to help. Letter B. I'm going to solve very similar. Solve b divided by negative 3 plus 4 is less than 13 and graph the solution. So split my inequality at the less than sign. First, I'm going to undo my addition by subtracting 4 on both sides. Subtracting 4 and adding 4 cancel out. I'm left with b divided by negative 3 is less than 13 minus 4 would give me 9. And then I have b being divided by negative 3. So to undo that, I would multiply by negative 3 on both sides of my inequality. And remember, from last section we learned this, when you multiply or divide by a negative number, when you're working with solving inequalities, you need to switch that sign. So b is going to be greater than 9 times negative 3 would give me negative 27. b is greater than negative 27. Yep. If I were to graph that, negative 27, as I go right, I'm getting closer to 0. And as I go left, I'm getting more negative. Open circle because it's not or equal to at negative 27, and that's where b is greater than that, so shade to the right. Alrighty, there you have it. Let me know if I can help you on those two at all, and I'll have you try the first 3 problems here for this inequality. Pause the video now and then come back to see if you got it correct. All right, I'll do the first one together, and then I'll let you, and then I'll just probably give you the answers for the other ones, and let me know if you didn't get them right so I can help you. So undo my addition or subtraction first. So that gives me 6y is greater than 12, and then divide by 6 on both sides. So y is greater than 2. Again, I'm not going to graph at this point. Let me know if you need help graphing. Here, this can be tricky because you might see this 4 here, and you might see this subtraction sign here. But remember, what's in front of this 4? We assume this is positive 4. Okay, so to move that to the other side, I would have to subtract 4, because 4 minus 4 is 0. Now I'm left with negative 3d is greater than or equal to 15. I would divide by negative 3 on both sides, and anytime I'm dividing by a negative, remember I need to switch that sign. So less than or equal to negative 5, and there's my answer. And number 3, undo my adding 8 by subtracting 8. I'm left with w divided by negative 4 is greater than, looks like 1. 9 minus 8 is 1. Multiply by negative 4 on both sides. So I need to switch that inequality because I'm dividing by a negative. And w is less than negative 4. If you have questions on any of those, please let me know. Example 2 here. You might notice that we've got some parentheses. And there are actually a couple different ways to do this problem, and I will show you both. So negative 7 times x plus 3 is less than or equal to 28. The first way I'm going to show you is what I'm going to actually do is I'm going to divide both of these sides by negative 27, or excuse me, negative 7 is one way you could do that. Or the other thing that you could do is that you could distribute this negative 7 inside the parentheses and then solve. So either way will work, and I'll show you that right now. So I want to isolate this, so I would divide by negative 7 on both sides first. Right? Negative 7 divided by negative 7 is 1, so that cancels out, and I'm left with x plus 3 is less than or equal to 27 divided by negative, or 28, divided by negative 7 would give me negative 4. And I almost made the mistake that's super easy to make. I divided by a negative, so I need to switch that inequality to greater than or equal to. Okay. Then all I have left to do is subtract 3 on each side. And x is going to be greater than or equal to negative 4 minus 3, chop chop, negative 7. Okay, that's one way to do it. A lot of students prefer that. They're just getting rid of the multiplying by negative 7 first on both sides. And then the other way that you can do it would be to distribute this negative 7 inside the parentheses first. Okay, so if I did that, negative 7 times x is negative 7x plus negative 7 times 3 is negative 21 is less than or equal to 28. So again, I just multiplied x plus 3 by negative 7. Okay, to get rid of this negative 21, I'd add 21 on both sides. So that cancels. I'm left with negative 7x is less than or equal to 49. And then I would divide by negative 7 on both sides. That would give us x is, I need to switch it around because I divided by a negative, greater than or equal to negative 7. So if you look, that's exactly what we got for the first method where we divided by the negative 7 first. Okay. So either method will work. I guess you choose the method that you prefer. And then which of those answers is the correct graph for A, B, C, or D? Well, I could eliminate a few because it's greater than or equal to. So I know that, and it's also a negative. So I can get rid of D and I can get rid of C because these are both at positive 7 and I need to be at negative 7. So A and B are both at negative 7. And it's greater than or equal to, so it needs to be shaded to the right. So that would be letter B is the correct answer. Okay. This is less than or equal to for letter A, so that's not correct. Okay. Go ahead and try 4, 5, and 6 here. Please pause the video now and kind of do it either way that you prefer. It's up to you. And then come back to see if you did them right. All right. I would divide each side by 2 first. 2 divided by 2 is 1, so that cancels. K minus 5 is less than 3. And then all I have to do is add 5 to both sides. So K is less than 8 for the first one there. Okay. Again, for this one, I divide by negative 4 on both sides. So flip my inequality. And minus 10 is greater than. Well, let's see, that would be negative 8. And then add 10 to both sides. So n is greater than 2. And then for this one here, I could divide by 0.5 on both sides. Let's see, dividing by a half is the same thing as multiplying by the reciprocal. So same thing as multiplying by 2. So half divided by half is 1. That cancels. And then I can think of dividing by half as the same as multiplying by 2. So negative 3 times 2 will give me negative 6. Is less than or equal to 8 plus y. To get y all alone, I would subtract 8 on both sides. Cancels. Negative 6 minus 8. Chop, chop. Negative 14 is less than or equal to y. And then I would rewrite that so that my variable is listed first. When I do that, I also need to reverse my inequality, so greater than or equal to negative 14. Kind of a doozy there. Lots of good math, though. Let me know if you had questions on any of those three. Okay, we've got the last example here, and then a little bit more practice for you to try a few out. So, example 3 reads, a football team orders the sweatshirts shown. The price per sweatshirt decreases 5 cents for each sweatshirt that's ordered. Kind of like when you order anything in bulk, usually it's cheaper. How many sweatshirts should the team order for the price per sweatshirt to be no greater than $32.50? And if you look here, it looks like the base price is $40 for a sweatshirt. Okay, it looks like we're ordering these for a football team. All right, so let's think about this. How could we figure this out? Well, let's kind of reword it. I know that the base price, I know that if I were to subtract my price discount from that, and I multiply that, so times the number of sweatshirts that I buy, I should just actually abbreviate that SS for sweatshirts, times the number of sweatshirts, that I need this price to be less than or equal to $32.50, which is what do they call it in here? I guess you could call it a desired price. Because you don't want to pay more than this, right? People don't want to pay more than $32.50. Okay, so let's stick in some numbers. I know that my base price is $40. I know I get a discount of 5 cents per sweatshirt. So 5 cents times the number of sweatshirts. Well, I don't know that, so I'm going to just call that N. So I get 5 cents off per sweatshirt. So that would be 5 cents times each sweatshirt needs to be less than or equal to that desired price, which I want it to be less than or equal to $32.50. Okay. So there is my inequality. Now I just have to solve it. Okay, so I would subtract 40 on both sides. 40 minus 40 is 0, and I'm left with negative 0.05 n. That's that nickel that I get off of each one, is less than or equal to, let's see, it's going to be 50, and it's going to be, I need to borrow, so negative 750. Okay. Last step, how do I get n all alone? Well, right now it's being multiplied by negative 0.05, so I need to divide by negative 0.05. Divide by negative 0.05. So essentially this is saying how many nickels go into $7.50. All right, a couple things happening here. These are going to cancel, I'm dividing it by itself, so I'm going to be left with n. I'm going to need to switch my inequality because I'm dividing by that negative. Well, think about that situation, guys. Do I really need to switch that inequality in the context of this problem? It says how many sweatshirts should the other team should the team order for the price per sweatshirt to be no greater than, so I'm going to keep that less than or equal to, and then what is 750 divided by 0.05? You can plug that into your calculator. I'm going to do that for you. It would be 150 sweatshirts. Okay. So if you would, please pause your video now and go ahead and try the more practice here for 7, 8, 9, and 10. All right. Hopefully you had a chance here to solve these. I'm just going to give you the answers. For 7, you should come up with D is greater than or equal to 5. For number 8, Z is greater than 14. For number 9, G is greater than or equal to -6. Number 10 says describe 2 different ways to solve this inequality. So remember, that's the situation where you could either distribute first or you could divide by 3 first. Either one should work for you. Okay. Number 11, you should get, it says, are the inequalities this and this equivalent, and explain? No, they're not. They give you different answers. If you need me to show you, please come ask and I'll be glad to do so. And number 12 is an open-ended, so there's actually quite a few different answers for this, but one would be -5x minus 6 is less than 19, because when you solve that, you'd get x is greater than -5. Okay, so let me know if you want more help on some of those, but just some good extra practice. And that does it for 4.7 here. Let me know if I can help you in any more ways. I'll be happy to do so. Solving two-step inequalities is just like solving two-step equations. All right. Thanks for checking this out. I'll see you next time.